So we've discussed till now the even bound states. So just a recapitulation of what we were doing in last lecture. So last lecture we were trying to find how many number of even bound state can be there. So by plotting the graph of tan hyperbolic Ka versus we plotted the graph of tan hyperbolic Ka versus 2ma v naught upon say h k h square minus 1. So what we did, we tried to plot these two up, and we found that there would be one even bound state. In fact, that one even bound state, the range of that energy values for that even bound state would come between minus 2 mv naught square upon h square and minus mv naught square. Is that clear? Bharat, samajh mein aaya?
Yes, sir. Anji.
Now let us think about odd bound states, right? So this is another question. So even bound state we have found. If we want to find odd bound state, so this equation number 4 is your odd bound state. You just remember
So
this.
cot hyperbolic.
And then you have, I think, we'll try to remain with tan hyperbolic only because uska graph mein jo fatafat se aata hai. So I'll make, and this is your odd. Okay. So I'll divide 2 by 4. I will divide 2 by 4. Is that clear? So that things will remain in tan hyperbolic symmetry.
Okay.
Okay. But instead now this particular thing will come. मतलब जो अभी चलो मैं करता हूँ. So I'll write the equation. So this was, I think, for odd was, I think, A 2mv naught upon k h square minus 1 e की power minus k, and you had, I think, b cos hyperbolic ka here. Just check it.
Yes, sir.
Here it was,
yes,
I
sir,
think,
yes.
b sin hyperbolic ka, and then we had some a e की power minus k. These were the solutions. This came from the continuity of the odd bound state, and this came from the integral of the Schrodinger equation from a minus epsilon to a plus epsilon for odd bound state. Is that clear? Now you divide these two expressions up, and you'll find that your answer is tan hyperbolic Ka is nothing but it is equal to 1 upon 2mv naught, and let us multiply it with a, and you have ak and you have h square, and then you have minus. Is that clear? So instead of you again do the same substitution, you write Ka as y, and you write gamma is equals to 2m a v naught upon, I think, h square. So I don't think there is an issue till now. So you'll get tan hyperbolic y is equals to gamma upon y minus 1 raised to power minus. थोड़ा सा ऐसा हो गया. You cannot help it, but this is how it is. Okay. So for odd bound states, one needs to solve this particular equation, and only then he can know how many number of odd bound states are there. Is that clear to you?
Yes, sir.
Okay, so let us try to make the graph of it. Let us try to make the graph of it. So first, see, जब भी कभी graph बना रहे हो ना, just try to do 2 or 3 things. One, try to find how it behaves on origin. Second, try to find how it behaves at infinity. Try to see how does it behave at minus infinity. And obviously, you will not say ki, if minus infinity is not there. Right here, I'm saying that only if it is a domain. So if it, let's say if we are discussing root over x, so I will not say ki find the value at minus infinity or find the behavior at minus infinity. So provided it is defined, it is like a limit exists at x equal to infinity or minus infinity, or you can somehow find the real behavior in real sense. Then see the behavior of the function at plus minus infinity is 0. Find the first derivative, at least first derivatives, to know that whether your function is increasing or decreasing. So in this case, you can clearly see that your function was decreasing because the derivative is minus gamma upon y squared. Gamma is positive, y square is positive, negative aage lag raha. So overall, this is a decreasing function. This is a decreasing function from infinity to gamma. We'll do all these curve sketching in one class only. Don't worry about it. So I'll do it today or probably tomorrow or someday. I'll do this curve sketching part. But overall, understand that this is how the graphs will be drawn. And tan hyperbolic will do there only. But for right now, you just make this graph. Like this is how tan hyperbolic looks like. Is that clear to you? Now,
yes,
let us do the graph. Okay. Now, either the so देखो tan hyperbolic will remain as ever. We have to see and we have to think about this. Now, in previous thing, we knew that at gamma we had 0. Previously, we had 0, but now it will be 1 over 0. Is that clear to you? Are you getting my point? What I want to say is now no longer at gamma is equal y equal to gamma, you will have 0. So
yes, sir. Yes,
this is a different graph altogether. So we'll have to start from the very start. So now as y tends to 0, gamma upon y would tend towards infinity. I would write that y upon gamma minus 1 would tend towards infinity. But how would 1 upon gamma by y minus 1 would tend? How would, where it would tend? It would tend to 0. So this particular graph, as y tends to 0, because at y equal to 0, it is not defined. So y tends to 0, it will start from 0. This is very much clear. This is very much clear. And as y tends to infinity, so if y tends to infinity, this will become, I think this will become 0. As y tends to infinity, this will become 0, isn't it?
Yes, sir.
Okay, and if y tends to infinity, this will become 0. So it will become 0. This will become 0 minus
Minus
1.
1.
I think this will become minus 1. But if it becomes minus 1, then the plots will come downside. Have I made some mistake? Just see if I made some mistake. I don't
No,
think I
sir.
made a mistake. नहीं, कहीं mistake नहीं है इसमें.
It's correct.
But अगर y minus 1 पे चला गया, then there will be need to now, because we want somehow intersection हो, बस now तो intersection हो गई. चलो देखते हैं. If y tends to infinity, just give me a minute. थोड़ा सोचते हैं इसके ऊपर. So we'll think upon it. So as y tends to infinite, so as y tends to infinite, this will become 0, and this is 0 minus 1 is minus 1. Okay. ठीक है. So मतलब what does it want to say? It says that as y tends to infinity, my tan hyperbolic, this particular graph, that is gamma upon y minus 1 की power minus 1 would tend towards minus 1. Okay. चलो देखते हैं. चलो एक बार ग्राफ बनाते रुको. And let us see the derivative of this particular function. So let me write this particular function as f of y, which is given by gamma upon y minus 1. We'll divide it into two parts. One part will be y less than gamma, and y, because y cannot be equals to gamma, because if y is equal to gamma, then it is not defined there. So I'll write y cannot be equal to gamma. So either we can write it for, like, are you getting my point? देखो हो क्या रहा है इसमें? This particular graph will be discontinuous at gamma. So there will be two cases. One case would be y less than gamma, and other case would be y greater than gamma. Is that clear? Because your function is discontinuous at gamma. This is the problem. That is why we are encountering some sort of difficulties. So let us first do the basics. So this is what we have done. Now let us find the derivative of this. So derivative of this would be, I think, derivative of this would be minus 1 gamma upon y minus 1, and then you have minus gamma upon y square. Is that clear? So overall, this particular thing would be there. This is your derivative. Let us evaluate. This derivative would be gamma upon y square, and then you have gamma upon y minus 1. Okay, and this particular thing will be positive if your y is less than gamma. Is that clear? This particular thing would be positive if y is less than gamma, because if y is less than gamma, only then it will be positive overall. So y less than gamma, it will be an increasing function. So if y is less than gamma, then fy is increasing function. Is that clear? And if y is greater than gamma, then things will change up, because if y is greater than gamma, then infinity case will also crop up. Now let us try to make a graph of it. So देखते हैं ग्राफ कैसा.
सर f dash, सर इन f dash y -2 नहीं आएगा वहां पे पावर में?
हाँ
डिफरेंशिएट.
सॉरी मैं मिस्टेक. सो तो ये भी नहीं देखना था फिर तो ओवरऑल हमेशा इंक्रीजिंग फंक्शन आएगा. Because now there is a power of -2, so it will remain positive always. So in fact, I will write my fy is an increasing function. I will write my fy is an increasing function, but still I will have to be cautious about y equals to gamma. And I will have to be cautious about y equal to gamma, because at y equal to gamma, there is a singularity. Is that clear? Here also there is a singularity. Well, you cannot say anything right about derivative also, because at y equals to gamma, this will become 1, 1 minus 1 is 0, and 1 by 0 ki power 2. Now, this is not defined. So we are considering the case for y less than gamma. Let us first make the graph for y less than gamma. Are you getting my point? And then we'll see whether it is required or not that we'll go beyond gamma. अब अपन एक काम करते हैं. Let us, थोड़ा सा ट्रिकी क्वेश्चन हो गया यहाँ से अपने लिए. कोई बात नहीं, जो है चलो. let us make the graph of it. So यहाँ से graph लाने की कोशिश करते हैं. Here we are making a graph. Okay, is that clear? Now, first let us make the graph of I think 10 hyperbolic first. So 10 hyperbolic I already told you. It starts to tend towards 1. It starts to tend towards 1. So it starts to tend towards 1. So this is how your 10 hyperbolic would look like. And this is your 1. Almost 1 की तरफ tend करेगा. Y tends to 50. Not exact 1, but always. Now, this particular graph, that is your gamma upon y minus 1 की power 1. Minus 1 की power minus 1. This also starts from 0 only. This we have seen. That at exact 0 it is not defined, but at 0 it is defined. Now, okay, is that clear to you? ये चीज समझ में आ रही है?
Yes, sir.
Now, let us see कि for what all अगर ये solution मिलता है, if at all there is a solution, it will always be less than 1. मतलब समझ पा रहे हो?
Sir.
Only if my fy is less than 1, only then I can have a solution, isn't it? Because अगर fy greater than 1 हो गया, then आप समझो ना, because 10 hyperbolic always remains less than 1. Is that clear to you?
Yes, sir.
So I'm trying to just figure out what are the values if fi is less than 1. So fi less than 1 means gamma upon y minus 1 की power minus 1 should be less than 1. And if I take minus 1 both side, it will give me gamma minus 1 greater than 1. दोनों side 1 upon कर दो. So it means gamma upon y should be greater than 2. And it implies that y must be less than gamma by 2. Is that clear?
Yes, sir.
So we are well within the range of y less than gamma. So we are well within the range of y less than gamma. Is it clear? So y less than gamma by 2 तक के लिए ही we will have some solution. Otherwise not. Is that clear to you?
Yes, sir. Yes.
ठीक है. अब देखते हैं कि if y is less than gamma by 2, if y is less than gamma by 2, what is my function like? So my function infinity तक तो जाने ही नहीं now. We are not interested in how does my function behave at infinity, because I have to only think about y less than gamma by 2. Is that clear? And
Yes.
we already know that my function's derivative, the function derivative is positive. The derivative of the function is positive. Here it is, I think. Okay, the derivative function is positive. It implies my function is an increasing function. Is that clear? If my function is an increasing function, it starts from 0. How would my function go? There are two possibilities. Either it will go from below, or either it can go all over above. There are two possibilities. Either it can go from this way, or either it can go this way. Is that clear? And you should understand that there is a solution at y equal to 0, but you already know that this particular thing is not defined at 0. So I will not say that y equal to 0 is a solution. So now there are two cases. Either it will go above tan hyperbolic y being less than 1. Fy is less than 1. Like fy is less than 1 for all these points. But overall understand this is a possibility that it can go above tan hyperbolic y. So there will be no solution here. And it is a possibility that the function starts from here and keep on increasing, and then there is a cut. So there is a one odd bound state. Is that clear to you?
Yes.
Okay. So if this is the case, then there will be no solution. And if this is the case, then there will be one solution. Is that clear? Now, one odd bound state can occur if your solution number 2 is there. So what is the possibility that your solution 2 would be there? Again, the same thing. If my derivative of the function f dash y at y equal to 0 is greater than the derivative of tan hyperbolic y. So let me write tan hyperbolic as gy. So if my derivative of tan hyperbolic y at y equal to 0 is less than the derivative of fy, what is fy? Gamma upon y minus 1 की power minus 1. If इसका जो derivative है at y equal to 0, if it is greater than derivative of this point, then the slopes will lie above. So obviously this graph will grow above this particular graph. Is that clear to you? देखो कभी भी जब दो curves compare करने होते हैं, don't compare the curves. Start comparing their derivatives. Start comparing their tangents. If I am saying that this is my graph, इसके tangents कैसे बनेंगे? तो कैसे बनेंगे? इसके tangent ऐसे बनेंगे. So obviously tangent इस वाले graph का ऊपर lie कर रहा है. So if the derivative of this graph at y equal to 0 when it starts is greater than the derivative of this particular function at y equal to 0, then obviously the slopes will lie above, that is the tangents will above, that is what I can say, that this graph will lie above this graph. Is that clear to you?
Yes, sir.
Okay, so possibility of, I'll write the possibility of intersection, or I would write the possibility of odd bound states. So if at all my odd bound state occurs, it can occur only if my dy of क्या था ये gamma upon y minus 1 की power minus 1 at y equal to 0 is greater than d by dy of I think 10 hyperbolic क्या था y at y equal to 0. Is that clear to you? Okay.
Yes,
So
sir.
only if this is the case, only if this is the case, then things can come up. Because if my this gamma upon y minus 1 की power minus 1, iska slope, if it is greater than 10 hyperbolic y, then obviously this graph will lie above. And only if my graph is certainly in this fashion, the slope is less than at y equal to 0, if it is less than 10 hyperbolic y, so obviously it will start from below. And if it starts from below and as it is increasing, so somewhere it will cut. That is for sure. Somewhere it will cut. Is that clear?
Yes, sir.
So there will be a one odd bound state in this possibility. So what is the possibility that there will be one odd bound state? One thing is clear, that we are y should be less than gamma by 2. That is very much clear, because otherwise there will be no solution. So this you have to remember anyway out. Now another thing we are doing from here. So if at all this is the case, now differentiate it, what will I end up getting? So I think I will end up getting the derivative will be minus, and this, even if it is not defined, then take a limit to it. So I'm taking a limit to it. So this will become minus 1 gamma upon y minus 1 की power minus 2. And then this will be minus gamma upon y square. Obviously, at y equal to 0, it is not defined. So I'm taking the limiting behavior. Okay? And tan hyperbolic will be, I think, what hyperbolic? Or I think not what hyperbolic. Tan hyperbolic का derivative क्या होगा? Just find. Tan hyperbolic होता क्या? So d by of e की power y minus e की power minus y upon e की power y plus e की power minus. So try to find the derivative and give me an answer to this. फटाफट से. Otherwise, this lecture will continue for the third lecture. I don't want to continue it for the third lecture. Just try to find it. So if I want to find the derivative of this, so what will be the derivative? I think this will be e की power y plus e की power minus y का whole square. And this will be e की power y minus e की power minus y का square minus. I think this is clear. This will be, I think, 4 upon. I think the derivative will be, I think, 1 at y equal to 0, because this is 2 per square, 4 by 4 is 1. So this will be less than 1. Is that clear? And this I have to take as y tends to 0 plus. So this will become gamma upon y square, gamma upon y minus. Is that clear to you?
Yes.
Okay. So what I would get is, I think if I just divide it, so I think थोड़ा सा tricky है, अभी इसका कुछ कर नहीं सकते. And just try to take y both sides. So this will give you gamma minus y का whole square must be greater than gamma. Am I doing it right, or there is some mistake somewhere? Okay, and as y tends to 0, this will become gamma square should be greater than gamma, and that would imply that I think 1 by gamma should be less than 1. So 1 by gamma or gamma should be less. This is how it is. Okay, so this is the condition. So 1 by gamma should be less than 1. Only then there is a possibility that your odd bound state would occur. Is that clear? And further, y should be less than gamma by 2. That is very much clear. So there are two conditions. There are two conditions that your odd bound state would occur. The first condition says that your 1 by gamma should be less than 1. And another condition says that your y should be less than gamma y. Is that clear? Only then your odd bound state would occur. Is that clear to you? And let's say the odd bound state occurs at point gamma naught. So gamma naught will be less than y by 2. Sorry, y naught will be less than gamma by 2. If at all the solution, जो solution आता है, let's say this particular solution, what I'm saying is, let's say it is y naught. Let's say this is y naught. So y naught has to be less than gamma by 2, isn't it? So if I just square it up, what I would get? I would get k square a square less than gamma square by 4. And I think a था ना? Y naught plus y को क्या लिया था?
Yes.
K square इसको लिया था. And now this k square is not even. This is now odd. So now I will write minus 2me odd upon, I think, kh ket square into a square should be less than, what is gamma? Gamma was, I think, 2m v naught a upon h ket ka square ka whole square. And then there is 1 over 4 also. So in any case, your odd bound state, if I want to write the range of it, it will be greater than, I think this will get cancelled. This will be 2 will come below. M would get cancelled with M. V naught ka square will remain V naught. H ket ki power 4 will remain H ket ka square now. Now, what about K? ये क्या आएगा नहीं क्या? K square A square है ना? So what I have written, अरे K क्यों आएगा? So K square was, I think, K square was what? Minus 2me upon h ket ka square, na? So this K will not come. Okay, so this will be minus, I think this. Is that clear? So your odd bound state, if it exists, and when it exists only if 1 by gamma is less than 1 and y is less than gamma by 2. And if it exists, then it has to be greater than minus mv naught ka square upon 2h ket ka square. Is that clear to you?
Yes, sir. Sir, 1 by gamma less than 1 कैसे आई condition?
Okay.
Gamma square is greater than gamma है.
Gamma square is greater than gamma. Okay. Or what you can do is you can either take this thing, क्या कर सकते, इधर की तरफ ले आओ, gamma square minus gamma कर लो, and then greater than 0 करके gamma should be positive, because gamma is already positive, so you don't have to pay the solution, pay heat to it. See, again I'm telling you, the gamma is already a positive quantity, so you write gamma square minus gamma should be greater than 1. Then gamma minus 1 should be greater than 0. Gamma is already positive, forget about it. It implies gamma should be greater than 1. ऐसा. Or you can write 1 upon gamma is less than.
Okay.
इधर मैंने क्या किया था? I just divided gamma square here.
Yes,
So
sir.
in the textbook, find this is given. 1 upon gamma should be less than 1. So I wrote in that fashion. Otherwise, you can write gamma greater than 1 in the same thing.
Okay.
Is that clear? So 1 upon gamma should be less than 1 and y should be less than gamma by 2. Is that clear to you? So these are the conditions for having for the existence of odd bound states. So existence of odd bound states, you have the following conditions. So for odd bound states to exist, this should be the case. And further, you know that odd bound state, if it exists, then E odd should be greater than minus mv naught square upon 2h ket square. Is that clear? Now my final question to you is, what will be the ground state? What will be the ground state? So as you're aware, I wrote that my even bound state would lie between minus, this was like this, I think, and here it was, I think, minus 2mv naught upon h ket square. Is that clear? And my odd bound state would be greater than minus mv naught square, I think. mv naught square hai, sorry, square upon h ket square. Now just look at it and just tell me what will be odd bound state. What will be ground state? Will it be an even state or will it be an odd state? So by just looking at the expression, ground state should be minimum. So you can see that your odd bound state are greater than minus mv naught square upon 2h ket square, and your even bound state is less than minus mv. So you can say that even bound state will be your ground state. Is that clear?
Yes, sir.
Okay, is that clear? Second thing that you should realize immediately is that while we were finding while we were finding while we were finding even bound states, we had no condition on gamma. We had no condition on gamma, but when we were investigating our odd bound state, we had a condition of gamma. So we can also summarize our result in this fashion, that if my gamma is less than 1, then we are clear that there will be no odd bound state. There will be only one bound state, and that is even. Is that clear?
Yes, sir.
And we already know that your gamma is 2ma v naught upon, I think, h cat ka square should be less than 1. It implies what? It implies your v naught. If it is less than h cat square upon 2ma, then you have only one bound state, and that is even bound state. That is like, this is the depth of the potential, or you can say the amplitude of the double Dirac delta potential. If this v naught is less than h cat square on twice ma, then you have only one bound state, and that is even. And if your gamma is greater than 1, then you will have two bound states. Now you will have two bound states. One would be even, other would be odd. And this even state would be your ground state, and this odd state will be your excited state. Is that clear to you? And this will happen if your V naught is greater than h cat square upon twice. I hope I've made the double Dirac delta potential clear to you. Is that clear?
यस सर, इट इज क्लियर। सर इसमें y टेंड्स टू इंफिनिटी वाले केस में हमारे जो -1 आ रहा था, वो ग्राफ में
अच्छा, वो
जो
ग्राफ में
कहीं पे।
कैसे आएगा? देखो, उसके लिए तुम्हें ग्राफ को एक्सटेंड करना पड़ेगा। मतलब मैं अगर उसको बनाने की कोशिश करूंगा ना ग्राफ को प्रॉपरली, तो मुझे क्या करना पड़ेगा? पहले दो केसेस बनाने पड़ेंगे। वो क्या रहा होगा उधर? फॉर एग्जाम्पल ऐसा कुछ हो रहा होगा। So if I want to make the graph of gamma upon y minus 1 की power -1, so let us do this, है ना? मतलब क्वेश्चन तो खत्म हो गया ना? So
जी
you've
सर।
understood the question. So validity of
यस।
solution was only if your y is less than, this particular thing is less than 1. So the physics is over. Okay, physics is over because tan hyperbolic को भी तो इंटरसेक्ट करना पड़ेगा इस ग्राफ के साथ। So उसकी कंडीशन
यस
ये
सर।
थी कि y should be less than, I think जो भी कंडीशन आ रही थी कि I don't know, मतलब भूल गया मैं, पर point is this कि वो that part that y should be less than gamma by 2, because if y is not less than gamma by 2, you cannot have a solution. Is that
ओके
clear to
ओके
you?
ओके।
Now let us come
यस
to
सर।
your question कि अगर ये ग्राफ को पूरा ही बनाना हो तो how would it be? How would it be? तो अपन देखते हैं, अपन इसको डिवाइड कर देते हैं 3-4 पार्ट्स में। The first part would be, I think, to write where this gamma would lie. So let us make a graph till gamma, and let us try to do it. And I hope I've done the physics part. I'm just trying to explain you कि इसका graph कैसे बनना चाहिए. So as
यस
y
सर।
tends to 0, this will become infinite. And overall, my function, I will write it as fy. My fy would tend towards 0. Because as y tends to 0, this becomes
यस
infinity, and
सर।
overall this will become 0. Okay, is that clear? Now, as y tends to infinity, my gamma upon y would become 0. 0 minus 1 is, I think, -1. And -1 raised to power -1 is again, -1 raised to power -1 is again, I think, I
माइनस।
should write it as, हाँ ठीक है, इसको मैं लिख देते हैं -1. Is that clear to you? ठीक है? And we'll try to investigate another two things. देखो, एक और चीज देखते हैं, 0 पे तो ऐसा हो गया. And another thing is that your f dash y, irrespective of what your gamma is, except for y not equal to gamma, your function is, I think, gamma upon y square, and I think gamma upon y minus 1 ka power -2. Is that clear to you? So this is overall positive one, because gamma is positive. Here gamma is a positive constant. So my gamma is a positive constant. अच्छा, एक और चीज जो
यस सर।
समझने की मैं यहाँ बना देता हूँ, जो हम लोग अभी just we were doing the first case, it will be like this. So this is your tan hyperbolic x. If your gamma was greater than 1, then this will be graph, and if gamma is less than 1, then it will go above. So there will be no solution, and if gamma is greater than 1, then only there is a solution. Is that clear to you? This was part that we already did with tan hyperbolic. Now we are trying to make this. We are trying to just make the graph of this particular thing. Okay. Now you see that your function, okay, also see how your graph can be made in the limit gamma minus and gamma plus. That is, just see how does this particular function behave to the left of gamma and to the right of gamma. To the left of gamma, how would be a function behave? Let us see that. If I just write gamma upon gamma plus h minus 1, key power minus 1, is that clear? Because this will give me an idea of how does my function behave at gamma plus h. And your limit h tends to 0. Is that clear? So we are trying to find the limit of the function towards the right of gamma.
Okay, sir.
Okay, now if I do so, what I would get? I would get, I think, gamma minus h upon gamma plus h ka whole square. Sorry, gamma plus h ki power minus. Is that clear? So this will get cancelled. And this will give me gamma plus h upon gamma, and there is their negative because minus 1 ko aise le. Is that clear? So it will become minus
Yes,
1
minus gamma.
minus gamma by h. So as h tends to 0, this will go towards minus infinity. Is that clear? Is that clear? And instead, if I just want to find gamma minus h, f of gamma minus h limiting value h tends to 0, then this will be, I think, the same thing, h upon gamma minus h it will become. And this entire power minus 1. Is that clear? And you will get gamma by h minus 1. And as h tends to 0, this will become infinity. Is that clear?
Yes, sir.
So what do we get? We get that my function is increasing, no doubt. That is absolutely fine. At 0, at closer to 0, that is to the right of 0, I am having the function starting from 0. So your function would keep on raising, keep on raising, keep on raising. And as y tends to gamma minus, that is to the left hand of the gamma, your function is tending towards infinity, that you can clearly see. And to the right of gamma, to the left of gamma, it is tending toward infinity, and to the right of gamma, it is tending towards minus infinity. Okay. Now this particular function will drop down here because you can see that that is the graph of the function, that the derivative of the function is also not defined at x equals to y equal to gamma. So exactly at y equal to gamma, you cannot have the answer. So if I have the left hand if I go towards the left hand of the gamma, I can see that my function is rapidly increasing and going towards infinity. And as I go towards gamma plus, my function will khatak niche aayega and will start from minus infinity and it will start converging towards minus. Is that clear to you?
Yes, sir.
This is how it will be. So there is a discontinuity. But this particular thing will never yield you a solution because tan hyperbolic anyway will lie above x-axis for all y
Okay,
positive. So this is a sort of understanding that I wanted to tell you. I mean, you asked me, so that is right. But physically, if at all there's a solution, it will only be a solution if your y is less than gamma by 2 that we found, because overall this particular function should also be less than 1. Otherwise, you'll not have a solution because anyway, tan hyperbolic y is less than 1. Is that clear to you?
Ji, sir.
So let us make a summary out of it because there are still quite 5 minutes left. So a summary would be that if I am discussing my double Dirac delta potential, I will encounter two cases. One case would be odd, other case would be even. So if my even case exists, then even energies are given by minus mv naught square upon 2h square, and it will initiate from minus 2 mv naught square upon h square. Is that clear? And if at all my odd states exist, then these odd state will be greater than minus mv naught square upon twice h square. Also understand my point. From the very comparison, you can write that your even bound states form your ground state. Okay. And further, if I do, what I can do is I can write one, that if my gamma is less than 1 and gamma greater than, not exactly this way, but not in odd and even function sense. If gamma is less than 1, then I will have two bound states, that is one even and one odd. And if gamma is greater than 1, if gamma is less than 1, I will have only one bound state, that is even bound state, and if gamma is greater than 1, then I have two bound states, right? ऐसी कुछ करा था, चेक कर लो यार इस पेपर की, गलती में गलत नहीं लिख दूं. If gamma is greater than 1, there will be two. Is that clear to you? Even would be a ground state.
Yes.
Okay. Further, if you just try to see, this was my potential. This is how my potential would look like. This is how my potential was there. So I had a double Dirac delta potential at x equal to a, and a Dirac delta potential, attracted Dirac delta potential at x equal to minus a. So I had this kind of double Dirac delta potential. Is that clear to you? This was minus v naught Dirac of x minus a, and this was minus v naught Dirac of x plus a. We had an attractive Dirac delta graph at x equal to plus minus. Is that clear to you? Now, if I try to squeeze it up, that is, if I try to say that my a tends to 0, then what will happen? If a tends to 0, that implies your y, which was ka, will also tend to 0. And if your y tends to 0, what was your gamma? Gamma was also dependent upon a only. Gamma was 2 ma v naught, so your gamma also tends to 0. Is that clear? So your equation tan hyperbolic y is equals to what? Gamma upon, I think, y minus 1. This, for even states, would converge to y upon gamma minus. So as y tends to 0, you can approximate your tan hyperbolic as simply pi. Is that clear? So you'll find that your y should be equals to,
There will be a minus 1 power minus 1.
no, only for even states I'm saying.
Okay.
Even.
Okay.
So as a tends to 0, how? Because see, in any case, in both of these cases, what would exist? Only a ground state would exist. So even if you have two bound state or one bound state, I'm saying your gamma tends to 0. So gamma tends to 0 means what? You are in the limit gamma less than 1. So you can only have this even state here. Is that clear to you?
Yes, sir.
Okay. So your evens, it implies your y, and this is an approximation that you can take, that if y is 0, tending to 0, then your tan hyperbolic can be almost written as y. That you can see on your own. So y is equal to gamma. And if I write y is equal to gamma, that implies what? That implies your y square should be equals to gamma square. And that implies k square, a square should be equals to 4m square v naught square upon h cat ki power 4. And then you can write minus 2m e1 upon h cat ka square is equals to 4m square v naught ka square upon h cat ki power 4. So you will find that your even bound state, almost when a tends to 0, your even bound state and only bound state, because now as a tends to 0, your gamma tends to 0, you have only single bound state. You will have only a single bound state, and that happens to be an even bound state, and that will be minus mb naught square upon 2h cat square. And that indeed should be the case. If you remember, this was the energy bound state for a single Dirac delta potential. So you can see that if your a tends to 0, this will actually become nothing, but it will converge towards 0 only. So if your a tends to 0, what does it happen? It is actually like converging both these Dirac delta function together at a point. Is that clear? So it is actually reducing it to this sort of Dirac delta function. I think there is a mistake somewhere here. I don't. Acha, ye 2 ho gaya. Is that clear? So basically, instead of v naught, you have not twice v naught. So obviously you can expect this, because when you had only one Dirac delta, you had this minus v naught Dirac of x, your energy state was, I think, minus mv naught upon 2h cat square. Now instead, if it is 2v naught, it will become, I think this will become minus 4 mv naught square upon 2h cat square. This will get cancelled. So instead, if you have minus 2v naught Dirac of x, then this will be it. And this is what you're getting. I hope I've been able to explain you the double Dirac delta potential in entirety. Okay?
Yes, sir.
Okay. So we'll do a lot many things. We'll do electrostatics and all those things. We are going to run things in parallel. I hope things are clear to you. No issues.
Yes, sir. सर हमने सिर्फ बाउंड स्टेट के बारे में डिस्कस किया, स्कैटरिंग स्टेट के बारे में डिस्कस नहीं किया कुछ।
किसके लिए? स्कैटरिंग स्टेट्स के लिए?
मतलब E greater than 0 वाला केस।
I didn't get your point. मतलब किसके लिए कह रहे हो? Sorry.
सर मतलब जैसे बाउंड स्टेट और स्कैटरिंग स्टेट रहती है ना, ई ग्रेटर देन
Scattering
जीरो।
states we'll do in the scattering we'll do
ओके
scattering
ओके सर।
we'll do scattering states. Once we'll start the scattering thing, we'll do scattering states for Dirac delta potentials.
ओके सर।
Okay.
थैंक यू सर।